Hello and welcome to this video on homebrew and aging. 12-year-old Chivas Regal, Tamdhu 50-year-old single malt, and Belveni 50-year-old single malt Scotch. These range from $50 United States dollars to $22,000 US dollars to $37,000 US dollars. What makes these bottles of Scotch so expensive is aging. Most people understand, to one extent or another, that aging makes homebrew better. This is especially relevant to those who make mead and wine. So what actually happens? Aging is complex. It involves many different interactions among chemicals within the brew, the vessel that holds it, and the environment it is aged in. The end goal is an evening of certain flavors, moderating of harsh tones, and adding notes to the profile. To begin with the barrel. As previously described in a video on tannins, the barrels that are often used for storage interact with the contents. For aging, these are often charred or toasted. This creates a layer of absorptive material that draws off unwanted flavors within the brew. In true barrel aging, this creates a layer of unwanted residue inside the barrel that separates from the brew, and when it is siphoned off, remains in the barrel. The barrel imparts tannins and other flavors to the brew as it ages. Among the flavors are lignans, and these create vanillin, and vanilla-like flavors, lactones for buttery flavors, and tannins. The degraded lignin creates vanillin flavors. This occurs via the excision of hexanous from the larger lignin compound. This is then enzymatically or chemically converted with the addition of a carbon-based group. This then strips a hydroxyl group, replacing it with a double-bonded oxygen. This is then further reduced to a carbon-hydrogen-oxygen group. Then there are lactones. These create the buttery flavors. More accurately, the lactones found in dairy are similar to those found in aging brews. This is a similar flavor, and as a consequence, it tastes more like butter. This is the converted form of malic acid in some cases. Malic acid converts to lactic acid, and lactic acid is softer and sweeter than malic acid. As part of the conversion, diacetyl is produced, and this adds to the nutty, buttery flavor found in aging. And finally, tannins give the dryness and sharpness found in young brews. The tannins are released and incorporated into the brew through movement of the barrel. This is related to the environment in which the brew is aged, and more on that later. In whiskey, the process of drying the barley involves peat. This imparts smoky flavors to the whiskey, and as it ages and these interact with other compounds, smoke-like taste is caused by phenols and antioxidants. Antioxidants bind with anything that has free electrons and then some. In this case, the phenols bind with more compounds over time, and form such complexes as phenylated carboxylic acid esters, and these taste like honey. Esters are an important agent in flavoring aged spirits and wine. Esters are largely produced by acids in the wash and later distillate of wine. Barrel aging turns these conjoined acids into esters via the breakdown and separation, followed by chemical reactions to transform. As a byproduct of the phenols, whiskey among other beverages gain color. Phenols, as previously described, giving red wine its color. The environment is important in aging. A dry environment concentrates the brew. As the barrel dries out, the water in the brew moves into the wood. This leaves less liquid content in the barrel, but the flavor compounds do not move. As a result, they have a higher concentration. Over time, this leads to a higher rate of interaction, up to a point. After a period of time, the brew moves towards equilibrium. This means the energy and activity has effectively decreased until it has evenly distributed amongst the contents of the barrel. The seasonal variation during which the brew is aged affects the flavor. Tennessee and Kentucky whiskies are known for this, as the barrels are stored in large barns or warehouses where the temperature fluctuates. This causes a shift in the porousness of the barrel. As the alcohol moves into the barrel and then moves out, it draws the tannins and other compounds from the wood. This leads to incorporation of flavors that create complexity. Higher heat imparts energy to the brew. This affects aging. Specifically, it reduces the time required for aging. This is one reason why tequila and rum are not generally marketed as an aged beverage. Unlike wine, spirits do not age in the bottle. This is often due to the higher alcohol content, preventing some of those complex interactions outside of the wood. The alcohol content changes the electrochemical properties of the brew. As this changes, so too does the interaction. Wine is higher in tannins, leading to lower protein and other contaminants of the brew. The combination of attributes means that spirits and wine can be aged to varying degrees and effects, and why wine, when in a bottle with a high tannin content, but relatively low alcohol content by comparison to a spirit, continues to age. The important compounds made or concentrated during aging are phenols for the floral tones, acetic acid and phenol for the honey taste, guaiacol for the pipe tobacco or smoky flavor, capric acid for dairy notes, vanillins, tannins, 2-methyl butyrylaldehyde for nutty cocoa flavors, synapaldehyde for smoky flavors, and seringaldehyde for smoke and cinnamon flavors. To summarize aging, it gives the brewer an opportunity to separate out unwanted products, an opportunity for the context to interact in a complex way and form new compounds that impart flavor and subtlety. In highly alcoholic beverages, this works with temperature fluctuations leading to highly complex interactions, whereas lower alcohol aging leads to less complex interactions, closer to a filtering process. This is also why artificial aging exists. That is another matter altogether. Thank you for watching this video. Please post any comments, questions, or suggestions you may have below.